In section 2.1, we're going to review the rectangular coordinate system as well as talk about what it means to be a solution to an equation. We'll also review how to calculate the midpoint of a line segment and how to compute the length of a line segment, otherwise known as the distance formula. First, let's take a moment to look at the rectangular coordinate system, which is divided into 4 regions called quadrants. These 4 quadrants are determined by 2 lines called the axes. The horizontal axis is referred to as the x-axis, and the vertical axis is the y-axis. Note that quadrant 1 starts at the top right because this is where ordered pairs have both a positive x-coordinate and a positive y-coordinate. Then from there we travel counterclockwise to quadrant 2 at the top left, then quadrant 3 at the bottom left, and finally quadrant 4 at the bottom right. Notice that depending on which quadrant a point is located in, its x-coordinate could be positive or negative, and its y-coordinate could be positive or negative. Of course, we can have ordered pairs that don't fall in any of the quadrants and instead fall on one of the 2 axes. There's one point in particular that falls at the intersection of the 2 axes, and that is the origin, which has an x-coordinate equal to 0 and a y-coordinate also equal to 0. Let's practice how to graph ordered pairs. Here I'm going to use different colors to designate the different ordered pairs that we're going to be practicing with. So let's start with the ordered pair -3, 5. So the x-coordinate is -3, which means that we're going to travel 3 units to the left of the origin, and the y-coordinate is +5, so we're going to travel 5 units up. That ordered pair will fall right about where I'm dropping the point. 3 units to the left of the origin and 5 units traveling up. Next, let's plot the ordered pair 3, 4. Because the x-coordinate is positive, we're going to travel to the right of the origin 3 units. And because the y-coordinate is also positive, we're going to travel 4 units up. So that's where that ordered pair would fall. Next, let's look at -4, -2. Here we have a point in the 3rd quadrant because both coordinates are negative. 4 to the left and then 2 down. Next we have 3, -4. Let's see if I can find a purple color. There it is. From the origin, travel 3 units to the right and then 4 units down. That point is going to fall in the 4th quadrant. Next, we have the ordered pair 0, 4. Let's see if I can find a brown color. That's going to be a little tougher. Maybe this one right here. 0, 4. 0 is the x-coordinate, which means that we're not going to travel left or right from the origin, but we're going to travel 4 units straight up. There we go. That's as close as I can get to that brown. The next ordered pair is -3, 0. So from the origin, we're going to travel 3 units to the left, but we're not going to travel any units up or down. Let me grab that orange color. And so we're going to drop that point right there. And finally, we have the point 0, 0, which is the origin. And of course, that is where the point is located. So in these ordered pairs, we have the green point in the 1st quadrant, the red point in the 2nd quadrant, the blue point is in the 3rd quadrant, the purple point is in the 4th quadrant, and then we have the brownish point, which falls on the y-axis. The orange point is on the x-axis, and of course, the black point is the origin. Let's talk about what it means to be a solution to an equation. And here we're looking at equations where the solutions are ordered pairs that fall in this rectangular coordinate plane. So a solution to an equation is an ordered pair such that when we substitute the x and the y coordinates into the variables of the equation, we get a true statement. So here, for example, if we have the equation y equals 4x squared plus 4, we can determine if the following two ordered pairs are solutions or not. Let's take a look at whether the first ordered pair is a solution. We can check this by substituting -2 for x and -4 for y and seeing if we get a true statement. So for example, -4 equals, and we'll put a little question mark here, does it equal 4 times -2 quantity squared plus 4? Ooh, I already see some trouble because -2 when squared gives us a positive 4. 4 times 4 is 16, and then 16 plus 4 is 20 on the right. So in this case, -4 does not equal 20, and so this would not be a solution. For the next example, we have the square root of 2 as our value for x and 12 for y. Let's see if this creates a true statement. Is 12, question mark, equal to 4 times the square root of 2 quantity squared plus 4? Well, 12 on the left, on the right, square root of 2 when squared becomes a 2. 4 times 2 is 8, plus 4, it looks like that is a true statement. Because that is a true statement, then the ordered pair, the square root of 2, 12, is indeed a solution.